if you have two categorical variables and you want to see whether the between the two category variables are related or not, we can do a test of independence, and this is called the chi-square test. So in chi-square test of a contingency table, we need to compare the observed frequency and also the expected frequency of occurrence in all the cells. So basically in chi-square test, we need to construct the contingency table. And in this contingency table, we will have the observed frequency and also expected frequency, and we will calculate using all this frequency in order to come up with a test statistic and then compare with the critical value and then decide whether is there any relationship between the two categorical variables. The test statistic from the chi-square test follows the chi-square distribution. So this chi-square distribution is a continuous and positively skewed distribution, and the values range from 0 to infinity. And in order to determine the critical value, we need to know the alpha level and also the degrees of freedom. So once we have the alpha level and the degrees of freedom, we can get the critical value from the chi-square table. For chi-square distribution, under the curve is 100%. So if you want to do the right tail test, so suppose this area is 0.01, and then we need to find the critical value, and then for the degrees of freedom, suppose is 4. So from the table, you look at degrees of freedom 4 and then go into chi-square 0.01, and you found the value is, the critical value is 13.3. Test of independence of two variables, the chi-square test. So as we did before, what we need to have in any hypothesis testing, any statistical test, is we need to write the state, the H null and H1, and then we need to calculate the test statistic, and we need to find the critical value, and always the critical value comes from the table, and then we decide whether to reject or do not reject H null. So in chi-square, the hypothesis H null is the two variables are independent, and H1, the two variables are dependent. So again, these two variables are categorical variables. And this is the test statistic formula for chi-square, whereby Fij is the observed frequency, row I, column J. Eij is the expected frequency for row I, column J. Row I is the row I total. Cj is the column J total, and N is the sample size. And this is the formula for the expected frequency in row I, column J, which is just simply multiplying row total and column total divided by N. So once we calculate the test statistic, we need to compare with the critical value. So the critical value from the chi-square table for this chi-square test is you need to have the alpha, level of significance, and also the degrees of freedom. So here alpha, we just use the alpha that we chose, and then for the degrees of freedom is r minus 1 multiplied with c minus 1, whereby r is the number of rows and c is the number of columns in the contingency table. As a rule of thumb, each expected frequency should be at least 5. Why? Because the counts that we use when we calculate the test statistic are discrete, but the chi-square distribution is continuous. So if the expected frequency is less than 5, then the approximation for the continuous distribution is unsatisfactory. So we are using this example to set up the contingency table. So in this table below is the information about the media that primarily people get news according to the age group. So we have a categorical variable, which is the media, which is categorized into local TV, national TV, and radio. So three categories. And also for the age group is in categories also, which is the first category, less than 36, between 36 and 50, and also bigger than 50. So we have this total, the age group uh, for the first column is 260, age group from the second column, the second group is 320, and the third is 420, and this is the total for the local TV, national TV, and radio, and so we have the grand total, which is 1000. And then at 5% level of significance, is there any evidence that there exists significant relationship between the age group and where people primarily get their news? So we want to see, is the category in media and also age group, is it independent or not? So first step is to state the null and the alternative hypothesis. So H null, there is no relationship between the age group and where people primarily get their news. H1, there is a relationship between the age group and where people primarily get their news. So we have media, three categories, and age group, three categories, and this is the values that we had before, and then we have in the parentheses the expected values. So the value that we had is called the observed frequency, and then we need to calculate the value in the parentheses, which is the expected frequency, and the expected frequency is just simply row total multiplied with column total divided by n. So if we have E11 means we need to multiply the total in row 1 times the total in column 1 divided by the grand total, the grand sample size, which is the n. So if we have E13 example, so meaning that to get E13, which is row 1, column 3, is just simply multiplying total in row 1, multiply with total in column 3, divided by n. So how do we get, example, this 89.7 as the expected frequency for this cell? So when we have 3 rows and 3 columns, we have 9 cells. So meaning that we need to calculate 9 expected frequency. So to have the expected this is row 2, E21. Okay, row 2, column 1 is simply multiplying total in row 2 and column in total in column 1 divided by n. So total in row 2 is, if you see this is row 2, then it is 345. Okay, and then multiply with total in column 1. So column 1 is 260. So 345 multiplied with 260 divided by the grand, the n, which is 1000. So that's how you get 89.7. So you need to get all the 9 expected frequency. Okay, so example here, 138.6. How do you get these values? So this is just multiplying the total in row, this is row 1, so total in row 1 multiply with total in column 3 and then divided by 1000. So in order to calculate the test statistic, okay, so we have the observed value, which is all in the 9 cells, okay, the first data that we had. And then we calculate just now the expected value, which is expected frequency. Okay, using the formula total in row I multiplied with total in column J and then divided by N, which is 1000. And we have all these 9 also values. So we have 9 values of Fij and 9 values of Eij because we have 9 cells, 3 rows and 3 columns. So to have the the test statistic, okay, so we need to subtract Fij minus Eij. So this one minus this one, then we square it because sometimes we have a negative value, sometimes positive. So we just want to look at the distance. We need to square it. So all are positive. We square the values and then divide by Eij. So we have all this for each of the cell, and then we need to add it up, and then we have 24.320. So this is the test statistic. Okay, so any test statistic we need to compare with the critical value. So we are using 5 level of significance 5%, which is 0.05, and then we need to find the degrees of freedom. So again, the degrees of freedom is row minus 1 multiplied with C minus 1. So how many rows? We have 3 rows, so 3 minus 1 is 2. How many columns? 3 columns, so 3 minus 1 is going to be 2, so 2 times 2 is going to be 4. So we need to find 0.05 for in the chi-square table. So this degrees of freedom for alpha 5%, 0.05. So the critical value is 9.49. So comparing the test statistic with the critical value, so we found that the test statistic is larger than the critical value. So therefore, the conclusion is we decide to reject Krishna. So conclusion means that there is evidence of a significant relationship between the age group and where people primarily get their news.